Welcome back to the Gregarious Technology YouTube channel. In this video, we're going to be doing a deep dive into DNS, everything you need to know about DNS. As an overview, what we're going to be covering is what is DNS? We'll discuss top-level domains, TLDs, public DNS versus internal DNS, and talk about the specifics on each one of those. Domain registration, the very specific DNS records that are involved in this process, the tool sets that we will use to register the domains and DNS records. In my demonstration, I'm going to use GoDaddy with my own domain. And we'll go through some tool sets that will also enable you to analyze and assess DNS. And then we'll look at some reference articles for further analysis and further discovery and further knowledge. So without further ado, let's jump right into it. So let's start with the basics. What is domain name services? When you sign up for an internet service provider, that internet service provider that provides internet access to your organization gives you an IP address or a range of IP addresses. Those could be IPv4 or IPv6, typically IPv4. So the internet is just basically a bunch of interconnected devices through routers, core switches, those kind of things. But the internet does not speak in human language. It speaks in IP addresses. Your router or your load balancer is assigned a 128-bit IP address separated by 4 octets. Each one of those are separated by a dot, a decimal. For us as humans, it's very inconvenient, almost impossible to remember IP addresses. So DNS comes into play to translate domain names into IP addresses. In my case, I have a domain name registered called daemon-cloud.com, and that translates through DNS to maybe several IP addresses, depending on the DNS records and the services that I want to provide through the internet. For instance, I might have services for Microsoft 365, I might have a web server, et cetera, et cetera. So we need to understand how that process works. For instance, daemon-cloud.com. We need to talk about the top-level domain and who is authoritative for those top-level domains and secondary domain levels. For instance, .com would be a top-level domain, and daemon-cloud would be a secondary domain underneath the top-level domain of .com. Now, at this point, we're strictly talking about public domain name resolution, not internal. When I say internal, I'm talking about internal DNS resolution to your corporate environment. For instance, most commonly Active Directory. How do you resolve DNS on your own corporate network? So it's a combination of both. At the top level domain, also known as TLD, you're talking about extensions. For instance, .com, .net, .org, .gov, .edu, .biz, .name, .us, .uk, .ca. There's a ton of top-level domain extensions, which are really the end part of the suffix of your domain name that you register with your domain name registrar, for instance, GoDaddy. So who is the governing body that is responsible for these top-level domain registrations that would pass it on to your registrar, for instance, GoDaddy, and responsible for security and maintaining those distributed databases over the internet? Well, it's a little complicated, but let's go through it. The Internet Assigned Numbers Authority, also known as IANA, oversees these TLDs, these top-level domain operators. It's run by the Public Technical Identifiers, PTI, an affiliate of the global domain management nonprofit Internet Corporation for Assigned Names and Numbers, which is known as ICANN. ICANN. So if we take a look at the webpage I have shown here, what is ICANN? What do they deal with? The main parts of a domain name that ICANN deals with are the second level domains and the top level domains. So the top level domain in my instance would be .com. The second level would be Daemon Cloud. So in a nutshell, the TLDs are authoritative for the domain extensions that we talked about, the domain suffixes, so the root ones, the .com, .net, .org, .gov, .edu, .biz, .name, .us, .uk, .ca, etc., a ton of them. These are the root level DNS servers. They maintain a list of the TLDs. They are the authoritative servers. And this is going to come into play when we take a look also at internal DNS with like Active Directory to make sure that your Active Directory DNS servers reach out when they're not authoritative for the zone. So you're going to have an internal DNS zone, and anything outside of that zone is going to reach out to, first the TLDs, and then the TLDs are going to hand it off to the second level domain queries. And ICANN is responsible for most of those. So when you register a domain with somebody like GoDaddy, as you can see here, GoDaddy is an authorized registrar that can register your domain with the TLDs with ICANN. So when you type a URL for a domain name into your browser, for instance, it's going to reach out to the root servers, and those root servers are going to have queries to the TLDs, and the TLDs are going to pass them off to the secondary registrations they have for each one of the top level domains in their databases. We have absolutely no control over the handoff between our domain registrar and the TLDs. This is just for informational purposes so you understand how DNS works. So now that we have an understanding of top-level domains and ICANN and IANA and secondary level domains, let's move on to the next topic. So now let's talk a little bit about domain name registration. How do we register a domain name or several domain names, and how do we manage those domains? But before we get into that, I want to point out something very important. When you go to purchase a domain for the first time, you always want to enable the option to purchase domain privacy. What domain privacy allows you to do is to mask your personal contact information, your name, address, email, phone, for the admin, technical, and billing contacts, etc., from the public whois database. So instead of your details, the public records show the contact information of the registrar or a proxy service protecting you from spam. So when I'm looking at my own domain as the registrar, I see on the left-hand side my personal contact information because I have to provide that to them. But what the world sees is this proxy. My private information is replaced with the registrar's information, so that that information is not made publicly available, and I won't receive unwanted emails and phone calls and all that kind of stuff. If we take a look at it from the public view end, and a whois search lookup, this is what it's going to show like. It's going to give you the basic domain information, but notice the registrant contact is blank. The registrar information is there, but my personal information is not in there. It just has a couple of contacts to report abuse or get information from GoDaddy, and that's it. So very important to add that on during domain name registration when you purchase a domain to protect your personal information. So what does the process look like to see if a domain is available and to purchase and register that domain? First thing you have to do is shop around a little bit for a domain registrar. I use GoDaddy, and so I purchase all my domains through GoDaddy. If you go to GoDaddy.com, first thing you're going to see right up top is the search for domains, and you just simply type in whatever domain you're looking to purchase and click on search domains. And boom, right there, it tells me I can make it mine. And if I click on that, we're going to have the option to purchase, enter all our registrar information, and again, choose the option for masking your personal information through domain privacy add-on. It's that simple. If it's not available, it'll recommend some alternative domain names and those kind of things. The user interface, the web interface, is going to be different for managing your domains depending on your registrar. For GoDaddy, it's pretty straightforward. I'm going to click on my account, go to My Products, and I'm going to see some of my domains here. I'm going to scroll down a little bit to manage the domains. So I can either manage DNS or manage the domain itself. We'll go ahead and click on DNS. And we're going to come up to the web interface for managing everything about DNS for that domain. And we could switch to our other domains by going up here and just simply typing in, select a different domain and choose one of my other domains to manage. If you scroll down, you're going to see all of your records. You can filter those records. We'll talk about these records in the next section. To the certain type. So you can view only, for instance, your mail exchanger records. Make it easier to see. And you can edit those from the edit button. Some more advanced features are underneath the Actions tab. If you are migrating from a different provider and you don't want to have to recreate all the DNS records that you had at your former provider for DNS, you can export from the former provider and import that zone file, which has all of the records in that zone for that domain. And you can export if you were going to move away from this provider, or just as a backup, so that if anything ever happens, you can easily import it again and easily revert from any mistakes. Just a reminder, this is the interface for GoDaddy. Depending on your registrar, they might have quite a different look and feel to their DNS web interface on how you manage your DNS records and how you register and all that kind of stuff, but the concepts are all the same. And that's pretty much it for domain registration, domain privacy, and basic navigation on how to manage each one of your domains. Next, we're going to get into the specific record types. Okay, so the first type of record we're going to take a look at is a host, also known as an A record or a host A record. A host record, an A record, maps a domain or a host name or a subdomain to an IPv4 address. So, for example, you might have your router, and your router has either a single IPv4 address or a couple that are load balanced or whatever. And you have behind that router corporate servers that provide services, maybe an ADFS server, maybe a web server internally, those kind of things. So you would create host records to reach the ADFS server, the web server, whatever it may be. Also, commonly, internet devices that are on your corporate network, but internet facing, so VPN. So you would create host records to point the host names underneath your domain names to those IP addresses, and the ports would be open on the firewall, and then when they hit that, network address translation comes into play and all that kind of stuff. So that's the definition of a host record. Some common host names underneath your host record are simply the @ symbol, and that is the one that is the default catch-all for anything that's not specifically created with its own record. So anything that goes to the domain name without a subdomain or a host record that's specified will go to the IPv4 address. Typically, this is used for websites, so you don't have to use www. Often, like, let's say you're hosting a website through WordPress or some other provider, they're going to ask you to point the @ host record and the www to the public IP address that they've assigned for your web hosting. I don't actually have a web server presence. I don't need one. But let's take a look at some that I've had in the past that are still just kind of ghosted out there on my DNS registrar for GoDaddy. Let's go to filters. And then let's just select a host. And take a look. Oh, did that not work? Maybe you have to hit apply. What I have that's kind of legacy, I just generically put in my public IP address for my private VPN I use. So good luck trying to hit that, because there's nothing open on my firewall, number one. And number two, as soon as I disconnect and reconnect my private VPN, that'll change anyways. When my boys were younger, I actually hosted a Minecraft server off of my own network. And so I just never got rid of that. So there's another example. I don't have a VPN device, but if I had a VPN device, I would create the host name, and we'll see that in a second, how to create these records that said VPN. And so, for instance, Minecraft would resolve to minecraft.damoncloud.com. Web would resolve to web.damoncloud.com, and www.damoncloud.com. So these two are actually defaults from GoDaddy. If you resolve those IPs or look them up in the tool sets we're going to take a look at later on, like NS Lookup or MX Toolbox, you're going to see that those are the default IPs for the hosting service on GoDaddy. I don't actually pay for the hosting service, but those are pre-populated IPs allotted to me for if I did purchase web hosting services through GoDaddy. Those would be the IPs that are allotted to my web hosting for those host names. So let's go through the process of adding a new record. It doesn't matter which kind of record. You'll see that in a second. And the options, at least when we select the host record, you're going to have different options for different records because there are different types. And for the host record, you're going to have to specify the host name and the IPv4 address and the TTL. So we're going to say it's a host A record. We're going to say test. And then, so that'll be like test.damoncloud.com. And then we'll put in the value. And the value is going to be the public IP address of whatever the service that you're hosting has for a public IP address. Now, the TTL is a time to live, and that's the refresh rate where it kicks it out to the internet servers that query DNS. And yes, it does depend on each internet server and what their refresh rate is. But if we want to force it out as quickly as possible, we can change this. I think on GoDaddy, the lowest you can go is 600, which is 5 minutes. Let's see. Yeah, see. It tells you right there, 600 and 604, 800. So if I wanted to push a DNS record change immediately, as best as possible, I would take the time to live, the TTL, down to 600. And we'll go ahead and we will save that. So if we were going to do a quick and dirty test to see if that record is populated and propagated throughout the internet yet, we could do an NS lookup from command line and do test.damoncloud.com. It's probably not there yet. Just to see if it's resolving yet. And what do you know? It has resolved, looks like, to the correct IP address. Yep. So 149.22.94.130. So taking that TTL down really did help. Now it's querying my own internet provider DNS servers at this point. We'll get a little bit more into telling that later on. I'm sorry, NS lookup on how to change the DNS server that it queries, but we're jumping ahead a little bit, so we're not going to get into that yet. Just wanted to show you that it actually did work and how host A records work. And we can either edit or delete any one of these host A records after the fact. If I go into edit, I'll be able to change any of this stuff. By the way, you do want these to be static IP addresses. There is dynamic DNS services. You can look into that if you're interested, where the service, is a cloud service and it updates your dynamically changing DHCP assigned address on your cable modem or your router, whatever it is, and periodically, like every 15 minutes or half an hour. So you could use that service, but we're talking about corporate networks here where they have static IP addresses. So if you were going to hit that Minecraft server that I have, that's an old service that's not even in existence anymore on an old provider I had. It wouldn't work. Or it's assigned to somebody else now. Who knows? It's part of a DHCP pool, dynamic host configuration protocol, where the IP address can change during the lease period. So I gave it a little bit of time to propagate throughout the internet, that DNS record that I just created, the test. And I want to see if that IP resolves and is reachable through the internet. So I'm going to do a ping on it. And boom, we're getting a reply. So the DNS worked. It's able to reach that IP over the internet and have communications. Later on in the video, I will show you a tool that queries the internet, all the major DNS servers on the internet, to see if your specific record, whether it's an A record, a CNAME record, a text record, an MX record, whatever, has propagated throughout the internet. And so you can validate that and assess how quickly it propagated and when the services are pretty much readily available throughout the internet. So now let's take a look at name server records, NS records. A name server record is the authoritative source for your registered domains in your DNS registrar for DNS resolution. Typically, the name server is co-located with your domain registrar, but not required. However, it's recommended to keep the same registrar and name servers unless a business use case demands moving the name servers to another provider. So, for instance, you might register your domain names with GoDaddy, but you might want to use another provider for the DNS resolution, the name servers, but it's not recommended. The name servers for each registered domain holds a zone file with all of the DNS records contained within that zone file for each registered domain. So you could have different name servers for each domain. When DNS queries from the internet are sent, they go to the domain registrar where you have your domains registered, and then they locate the name servers listed in your DNS registrar, and then they resolve DNS records for the name servers via the name servers listed on your domain registrar, and subsequently query the zone file listed on the name servers that are specified in your DNS registrar. For example, TXT, MX, CNAME, alias records. We've already seen how to import and export those zone files if there is a migration needed. So one use case would be we're migrating from one DNS registrar to another, and we want to host our name servers in the new DNS registrar. And before we transfer the whole domain, we want to move the name servers to our new DNS registrar and export and import the zone file into a new registrar before we actually transfer the domain names, because that could be a little involved. You might have to wait for the expiration. So, that might be one of the use cases where you would specify in your legacy DNS registrar provider that holds the domain names until you transfer those domain names. The name servers that would provide resolution for those domains that you have registered to your new registrar and export and import those zone files and, do a couple step migration on DNS. A bit of warning about web service providers, especially if they're freelancers or small shops. The web service providers often want to take over the name servers and DNS configuration. Do not do that. They know very little outside of web services, DNS configuration. DNS involves so much more than that. All your Microsoft services, your Google services, your on-premises servers, your VPN services, any services that you want to provide outside of web services, do not allow them to do that. They can come to you for creation of the DNS records. You do not want to have to wait for them to be available. You don't want to have to wait for the ticketing system. You don't want to have to rely on whether they get those records correct or not. Do not hand this off to anybody else. You should control your own DNS namespace. So how do we control that? Again, I'm using GoDaddy as my platform. Let's scroll down a little bit. If I were going to filter to only name server records and click on apply, I'm going to see that my name servers are co-located with GoDaddy. These are the GoDaddy name servers. Okay. I can't edit them from here. So if I wanted to change them, I would have to go to, scroll up to where it says name servers and click on that. And then click on change name servers. Again, not recommended. Let's co-locate them unless there's a really valid business use case for changing name servers. And then, of course, you would click on, I'll use my own name servers. And you would specify the name servers that are provided from your new DNS registrar. Now, when you do that, be careful because you're going to start off with blank zone files. That's where the export and import comes into play. So let's close this out. Now, the method is going to change a little bit depending on where you're coming from and going to. But in GoDaddy, if we went to DNS Records, and then we went down to Actions, here's where we could export the zone file. to be able to import into a new domain registrar once we transfer the name servers. And so the import process on the new name servers would look differently than GoDaddy, but that's the basic process. But again, I want to reiterate that you want to control your own DNS records. You want to have your name servers registered and co-located with the service that you have control of. Unless there's a serious reason to move those name servers, unless you're migrating, do not do it. And if you're migrating, make sure you still have control over those name servers and records. Do not let your web server provider control those records. So now we're moving on to an MX record, a mail exchange record. This record is a type of domain name system DNS record that specifies which mail server is responsible for accepting email on behalf of a domain. So if you have multiple domains, again, you have to specify an MX record for each domain. It acts as a set of instructions for the internet telling incoming email servers where to route messages for a particular domain, ensuring that emails are delivered to the correct mail server. So this could be routed directly to an online mail service such as Exchange Online or Gmail, or directed to an on-premise Exchange server, or it could be a third-party mail gateway and hygiene service such as Barracuda or Proofpoint, which those services would then relay through their, mail hygiene systems to any of the above. So when I say mail hygiene, that means basically spam, spoofing, and malware. If you're going directly to Gmail as an online service or Exchange Online, they have their own online protection services that you have to configure. So let's first take a look at Exchange Online. How do we know where to point the MX record to for going directly to Exchange Online with Exchange Online protection and no third-party mail gateway, hygiene, appliance, cloud, or on-prem in the mixture? First thing we need to do is we need to log into admin.microsoft.com as either a global administrator or a user with the organizational management role in Exchange Online. Then we're going to click on the search bar up top here. And we are going to type in domains, settings, domains. It's important to realize that if you have multiple domains, you have to set up an MX record for each one of the domains. So I'm going to click on the first one here as a demonstration. And then I'm going to click on DNS Records. So this is not only going to give me my Exchange Online DNS records, but any of the other Microsoft services. So I'm going to go ahead and click on that. At this point, we're only concerned with the MX record, but notice that there are several records that we need to do for Exchange Online. They're all listed underneath here for Microsoft Exchange. The text record, the TXT record, is for the SPF, which we're going to get into in a little bit. And the CNAME record is for auto discover, so that your Outlook app knows how to auto configure itself. But we will get into those records later on as we discuss those other type of records. So if we click on the MX record, it's going to bring up a window. I've already got it configured, but just for demonstration purposes, what you would do is click on copy that record. Then we would want to go to our DNS registrar with our name server, and probably want to click on filters again and just select MX and apply. And if we didn't already have this configured, we would create a new record. Again, it's right here. And we can have multiple MX records, by the way, and they're failover by priority. So we could add a new record, and we could say MX. And what we want to do here for that domain is just specify @ for all mail for that domain. And I've already got 0 specified as the highest priority, but we could do 10. They go by a multiple of 10s. And then I would literally just put in what I copied from Microsoft and then click on save. But if we look, we're going to see that I already have that present. So the priority is basically like failover. Like if you had an instance where you had several instances of mail gateways, you could provide each one of them here. But that's all there is to the Microsoft Exchange Online MX record. For Exchange on Premises, what you need to do is click on Add New Record. And then what you want to do is specify it's an MX record. You want to specify that the name is the root domain for each domain. Probably specify the priority as 0 unless you have multiple mail gateways, and then put in the IP address of the public IP address that would reach the Exchange server on premise. And of course, you want to make sure that the firewall permits SMTP traffic through ports 25 and 587, and set the TTL to whatever you need it to be. Make sure that you configure Exchange on premises accordingly, but that's beyond the scope of just DNS here. And then you would just simply click on Save. For Gmail, Google, you would do a very similar procedure. You would add a new record. Click on MX. Click on @ for the entire domain. Probably put 0 in for most purposes. And then you're going to put in smtp.gmail.com and save it. Remember to repeat this process for each domain that you have registered in your provider, your registrar. For any third-party mail gateways / services, what you're going to have to do is take a look at the service and grab the SMTP mail gateways from that service, whether it's Barracuda or Proofpoint or whatever, and fill this in a similar method. Most of the time, you're going to have multiple load balanced gateways, and you're going to have to add them individually as priority 0 and 10. So once we have set those MX records or MX records record appropriately, what we want to do is just do an allowed time for propagation. Is we want to do just a really quick check through NS Lookup. So we're going to go into the command prompt and say NS Lookup. We're going to say set type equal to MX. And then we're just going to quickly type in the domain that we want to query for the MX record. And boom, we got it. Now, if we really wanted to be sure that it's resolving publicly and not through ADDNS, we could say specify the server, public DNS server that we're querying, and do the same query. I set the query server to 8.8.8.8, which is DNS.Google, a public DNS server, so that I'm ensuring that my DNS queries are not going through a local server such as Active Directory, and that I can test what the public queries would be on the internet. And now we have a validation that our public DNS queries are working for this domain. Just remember that each domain has its own MX record, so don't forget to do that. So now we're going to get into text records, TXT records. What is a TXT record? What are the common use cases and some examples of those common use cases? A DNS text TXT record is a type of DNS record that stores plain text to provide information about a domain used for purposes like verifying a domain ownership and enabling email authentication methods like SPF, DKIM, and DMARC. So, filtering my records, my DNS records, to TXT records, we see 3 that I have, the 3 most common use cases. I have a text record, which is an SPF record. We'll talk about that in a second. I have one that is for domain ownership validation for Microsoft 365. And I have one that's for DMARC, which is for domain security. It's important to note that even though SPF, DKIM, and DMARC all work together, DKIM, domain keys, is actually a CNAME record, not a text record. So when we talk about CNAME records, we'll get into DKIM. So let's first talk about an SPF record. SPF stands for Sender Policy Framework. This record is a type of a DNS text record that lists the authorized IP addresses and servers that can send email on behalf of your domain. And if you don't have the SPF record configured correctly in your domain, the recipient organizations may reject your emails based on their policies that they have because they don't trust your domain for sending that. So these might be, for instance, your cloud service such as Microsoft 365 that definitely wants to be listed in there. But it also might be your organization's public IP address because you have relay devices and applications inside of your organization that send out through your public IP address, and you want to trust those so they don't get rejected by the recipient organization email servers. So you would add a text record, just like any other record, depending on your service provider again. And it's going to ask for certain information. It's going to ask for the name, value, and TTL. So let's start off with a text record. Now or an SPF record, I'm sorry, as a text record. Now you could create the SPF record by hand. And if you're going to do that, you're going to have to specify the @ symbol for the entire domain so that anything coming from that domain specified in the value characters would be allowed to send email through that domain. But and I'll show you a good site for checking out the syntax on this. This is a really good site for reference on the SPF record for the syntax of the text that needs to be in that. So if we scroll through this, we're going to see a lot of good stuff, some examples of what we call hard fail and soft fail, and some explanations on that. We're going to find the IPv4 or the IP4, which is for IP addresses. We're going to find the A, which is typically used for domains. So in an SPF record, you can include domain names and IP addresses. So for instance, I might want to use the Microsoft tenant name that my Microsoft tenant is allowed to send email. But it's actually kind of a requirement if you don't want emails rejected. But I might also want to specify the IP address, my public IP address of my corporate network that would be responsible for any relay servers and applications coming through that public IP address so that they don't get rejected. So this is a pretty good site for checking out the syntax and figuring it out. However, there's an easier method, and that's what we're going to go over. I want to introduce you for the first time to one of my favorite DNS tools called MX Toolbox. So if you go to the link shown here, they have an SPF record generator, and it's really, really useful. Let's go through that. So the first thing I have to do is type in my domain name. And if you already have an SPF record, it makes sense to pre-fill with the record found. In this case, I do want to do that because I don't want to start from scratch. I want to just add an IP address along with my Microsoft 365 Exchange Online address. And then I'm going to click on Check SPF Record. So we're literally just going to click on this checkbox right here after we add the domain name and also, in this case, pre-fill. And what we're going to see is on the right-hand side, it's going to give you the current, suggested record, which is right here. And at this point, it actually matches my current record because all I have in there is my Microsoft Exchange Online services. So as we go through this wizard, it's going to ask you some questions. Do you send it from your web server? And you can select yes on that. And you can go through that. It's always a good idea to select yes to do you send email from the same server in your MX records, so that auto populates. Any other host name, you could fill that in. In my case, I'm simply going to type in an IP address for my public IP address. And of course, this is my private VPN, so it's not really going to make a difference, but just for demonstration purposes, to allow email to be credited or recognized or secured as an authorized SMTP mail relay server for my domain. Remember, this is on a per domain basis. So if you have multiple domains, you are going to do this for every domain that you have. So in my selection, I've entered an IPv4 address. I don't use IPv6, so that's not important. This is kind of important. If you use HubSpot or anything like that, you have to contact the third-party bulk mailer service to find out what that service URL is going to be, and include that. And lastly, how strict should it be? I typically do a soft fail. I'm not going to get into all the email security stuff on a soft fail and hard fail. That's beyond the scope of DNS, but you have a couple of choices in there: soft fail and hard fail. Strict actually is a hard fail, or neutral. Okay. And as you add those values along the way, it's going to tell you what the suggested value should be. And you can grab that value, copy and paste it into your DNS provider, and use that for the SPF record. That's the easiest, quickest, and fail-safe way to get your SPF record correct. So let's now move on to a text record for domain ownership and validation. We'll use Microsoft 365 via Azure to show you how to add a domain in Azure and validate that you're the owner of this domain in Azure using a text record. So in a web browser, you're going to navigate to portal.azure.com. Then you're going to click on Microsoft Entra ID. Then you're going to scroll down to custom domain names. Click on that. And then you're going to click on add a custom domain to have that domain available for all the services in Microsoft. But of course, you have to prove that you own that domain. And that's the whole purpose of the text record. So I'm going to just type in something here. I don't actually own this domain. It's just for demonstration purposes. Let's go ahead and click on add domain. All right. And then we're brought to this screen where it says, here's the text record that you need to create. And it's going to tell you everything you need to know about creating this text record. So obviously you would have to have this domain name registered in your registrar to be able to do this. I'm just going to show you how to create the text record underneath a different domain because I don't actually have this domain registered and I'm not going to buy it just for demonstration purposes. The important part is just copy to your clipboard the text data that you need because it's going to be for the host name for your whole domain. So we're going to go back to our registrar and click on the domain name that we registered. And we're going to just click on and in this case, I don't actually have the domain name registered, but just show you what it looks like. And then we will click on save. And once we click on save, that text record will be added to our registrar, and we will be able to go back to Microsoft once that record has propagated throughout the internet, and we can click on verify, and it'll reach out to see that that text record is underneath the zone file for the registered domain name that you specified in Azure AD, and it'll verify the domain, and it'll be usable inside of Azure and Microsoft 365. So the last example of a common text record we're going to talk about is DMARC. It's worth noting that I have a whole separate video on SPF, DKIM, and DMARC, so I might not go into as much detail in this video. We're just talking about creating DNS records, but this is an important one. So what is DMARC? DMARC is known as Domain-Based Message Authentication, Reporting, and Conformance. It's an email authentication protocol that protects a domain from unauthorized use, like phishing and spoofing. So it protects against phishing and spoofing. It works with SPF, the Sender Policy Framework we just talked about, and DKIM, which we will talk about a little bit, or at least show you how to create a DKIM record when we get to CNAMEs. DKIM stands for Domain Keys Identified Mail, to verify that an email is actually sent from the sender it claims to be from. So here's a good article on all the syntax in an SPF record and all the options. I advise reading through that for your specific use case. In my use case, I'm simply creating the DMARC record, as you see below here. And I'm using the bare minimal syntax in my DMARC record to say, yes, it's a DMARC record. My policy is none. I keep it at that because I've had problems with saying, the policy basically says, what do you recommend to the receiving email organization? If I set it to quarantine or some other option, sometimes the receiving party has issues with email delivery. So I leave it up to the receiving party on how to handle the policy. And then the RUA is basically the reports email address for any of the DMARC reports, so we can keep a track on email delivery through DMARC. So it's pretty straightforward. We would just, like any other record, add new record, and then simply choose text at, and then put our syntax in there for whatever we've determined to be the syntax we need for our DMARC record. And that covers pretty much all the common use cases for text records. Okay, so now we're moving on to CNAME records. A CNAME, or canonical name record, is a type of DNS record that maps an alias domain to a different true domain name. Instead of pointing directly to an IP address like an A record, CNAME points to another domain. This is commonly used for subdomains. A bit of advisement or warning: if you're using CNAMEs with SSL certificates, secure socket layer HTTPS stuff, when it goes through a redirection with a CNAME, you want to make sure that that certificate is either a SAN, subject alternative name, and if it is a SAN certificate, that you have all the aliases on that certificate, or a wildcard certificate. Otherwise, you may get a warning each time that CNAME is redirected, or it may not work altogether. So we will take a look at CNAMEs through the lens of Microsoft 365 and the common CNAMEs that you will find there. If we go to admin.microsoft.com and we navigate to domains, find our domain, and then click on Manage DNS, we're going to find all the DNS records that we need for each service. So the first one is Autodiscover for Exchange Online. We always want to have the Autodiscover record populated in DNS. This allows for Outlook, when you type in your username and password, to automatically configure Outlook for the tenant, or if it's Exchange on-prem, the same thing. Scrolling down, Skype for Business is not really even used anymore. We're going to take a look at both the Intune and domain keys. First, Intune. So for Intune, we want to have both of these CNAMEs in DNS. And this is for Intune enrollment. Scrolling down even more, we're going to find the domain keys for email authentication listed as well, but that's a little bit of a different process. Now, the interesting thing is, if we just simply went to Add DNS Records and clicked on that, it's going to bring us to a window that allows us to authenticate to GoDaddy and have Microsoft, once we authenticate to GoDaddy, automatically create all these records. So that's a really quick and easy and fail-safe way to do it. However, we're going to show you the way to do it manually outside of that. Doing this manually, we need two bits of information: the host name for the CNAME record and where it points to. And then we would simply do the same thing we did for everything else. We'd add a new record. This time we choose a CNAME, and we would grab those bits of information. And paste them in, and it's as simple as that for every service that you want, and then click Save. Filtering my DNS records for what I already have, you can see I already have the Auto Discover record in there, and I also have the Intune records for enrollment as well. And there's some generic ones that GoDaddy just adds in there in case I ever add those services, but I don't really use those, so it's not like I really care about those. So for DKIM, there is an additional step. You have to actually enable DKIM in your tenant. You're going to have to go to security.microsoft.com. Then you're going to have to go to Email and Collaboration. Then go to Policies and Rules. Then go to Threat Policies. And then go to Email Authentication Settings. And then we're going to click on DKIM. And you simply enable DKIM for each one of your domain names. Now, remember that you're going to have to create those CNAME records for DKIM for each one of your domain names. It's not a one and done. And there's really nothing more to CNAME records. That's it. Let's now go over a few tool sets that we can use to query and validate DNS. The first is just a command line utility called DNS Lookup, and we talked a little bit about that earlier. One bit of advisement on this is that when you run DNS Lookup in your local network, it will be querying your local DNS servers. So if you want to query public DNS, you're going to have to set that server to a public DNS server. So, for instance, we will say that the server is a Google server, so that we're going to query from public DNS. And then we're going to set the type of record that we want to query. So in this instance, we're going to say set type equal to MX. And then we're just going to type in the domain name. And so we just queried Google's public DNS server for a return record on the MX record to see what it's returning. And we could do the same thing for NS records, TXT records, CNAME records, all that kind of stuff. We may wish to query local Active Directory or local network if there's non-Active Directory DNS servers without setting the server, just to see if we get a different zone file and record response from local DNS and would get from public DNS. So keep that in mind. Another great tool set I use all the time is what'smydns.net. And this is, as it lists here, a DNS propagation checker. And if we read what it says what's my DNS.net lets you instantly perform a DNS lookup to check a domain name's current IP address and DNS records information against multiple name servers located on different parts of the world. So if you just set a DNS record and you wanted to check that specific DNS record to see if it's propagated throughout the internet on different internet DNS servers, and see if there's some that are failing or some that have not propagated yet, especially during a migration, this is a very useful tool. It's as simple as selecting the record type and then the host name and domain name, for instance, test.damoncloud.com, that text record that I had created, and click on search. And it'll tell you how it's propagated throughout the internet. So you can see there's a couple of servers that DNS record is not propagated to yet, a few of them. But for the most part, most DNS servers on the internet have propagated that, and it should be resolved throughout the internet for the most part. We can repeat the same thing using an MX record for the root domain. Clicking on search, and we'll see the results from that. You're always going to get a few that, I don't know, just weird places like Russia, China, Singapore, Mexico. I don't know that those really matter. Or at least those specific DNS servers in that country aren't getting the propagation, and other DNS servers in those countries may be. So it's not like it's critical. Probably the greatest tool you could have for DNS troubleshooting and validation is MX Toolbox. Definitely bookmark that one. If you go to mxtoolbox.com, it's going to land you on the default page for an MX lookup. And you can hit that for an MX lookup. And it's going to give you a whole bunch of information. It's not only returning the results of the MX record, but it's also giving us some recommendations on additional tests down here on stuff like DMARC. But you can always go to the specific tests up top, like this blacklist. That's a very important one. Again, we're not going to get into all this because this is a video on DNS, but if you want to check and see if your domain name or IP is blacklisted, if you want to analyze headers for mail flow, all that kind of stuff, email health diagnostics. But let's go to DMARC because that is a DNS record. And because it gave us some warning about that, we'll go ahead and click on Daemon Cloud and do a DMARC lookup. And everything passed except for it just gives us a warning on the DMARC policy is not enabled, but that was intended. I just said none on the DMARC policy because I want to eliminate the issue that we might have mail flow problems if I specify that the receiving server should accept my policy of quarantine or reject, and there's some issue there. So I can ignore that, but it tells us that yes, we've got a DMARC record published, syntax checks out, multiple records, external validation, all that stuff looks really good. So the only thing it's complaining about is the part that says policy is equal to none. You can set that to quarantine or reject, but in my experience, that could lead to problems, and I don't care about that. But a really, really great tool set. Tons of tools in the tool set. Bookmark that, use it. Probably one of the best tools on the internet for all sorts of DNS stuff in mail flow and analyzing headers and blacklists and all that kind of stuff. With these three tool sets that we've discussed at your disposal, you're going to be able to do a really good job at analyzing and troubleshooting any DNS issues. So that pretty much wraps it up for the tool sets. So now it's time to move on to our last topic, Active Directory DNS, internal DNS. Now this is a pretty big topic. I want to do a deep dive, but I don't want to go down a rabbit hole. Quite honestly, I don't want to make the video 17 hours long, but I think we can do a sufficient job covering most of this at a pretty deep level. So we first need to get a few key terms out of the way for Active Directory DNS. The first is, what is an Active Directory integrated zone? An Active Directory AD integrated zone stores the DNS data in ADDNS rather than a file and is available only on domain controllers that have the DNS server role installed. So we'll pause there. When you install a domain controller, you should always leave at the default to install a DNS server as well. The Active Directory domain controllers replicate with each other, and as part of that process, they're going to replicate DNS, and that would be an Active Directory integrated zone for the domain namespace that is your Active Directory domain or forest. I'm not going to get too deep into the forests and domains in differences, but basically when you install a domain controller in the domain, whether it's a domain in a forest, a single domain, single forest, or whether it's a subdomain in that forest or multiple domains in that forest, that domain controller would be authoritative for that domain that you're installing into that domain controller into for that domain when you install the domain controller. So this model of Active Directory integrated zones allows for the multi-master replication, which we kind of alluded to earlier, meaning that any domain controller can process updates and replicate changes automatically to all other domain controllers in the specified scope. And again, when it says scope, for the domain that you're entering that domain controller into and is authoritative for. Key benefits include simplified deployment and enhanced security through dynamic updates. Inside of that integrated zone, you're going to have automatically created a forward lookup zone for the domain namespace of the domain that domain controller is added to when you do AD integrated zones. So what is a forward lookup zone? A forward lookup zone is an Active Directory forward lookup zone. It's a DNS database that stores records for a domain, mapping host names to IP addresses, which is very similar to public DNS with host A records. For example, www.damocloud.com would map to a certain IP. When a DNS server is promoted to a domain controller, it automatically creates an Active Directory integrated forward lookup zone. We talked about that, which allows for enhanced security, replication across domain controllers, and automatic record management for domain joined devices. These zones are fundamental for name resolution, enabling clients to find resources on a network using their familiar names, their FQDNs, or fully qualified domain names. Reverse lookup zones are not automatically created when you add the first domain controller DC to an AD domain, but they are replicated after that point to all DCs that are replicating to each other in that domain or subdomain or forest. An Active Directory AD reverse lookup zone is a special type of DNS zone that maps IP addresses back to their corresponding host names using a pointer PTR record. Unlike regular forward DNS lookup zones that look up an IP from a host name, a reverse lookup zone performs the opposite function, which is critical for network security and troubleshooting. These zones are typically integrated into Active Directory to add and provide a centralized and secure way to manage them. It provides security, aids troubleshooting, and device identification. For instance, with a reverse lookup zone in place for each subnet on your corporate network, you can perform an NS lookup by IP address to resolve the host name as part of security and troubleshooting. So, for instance, if we were going to go to a command line or PowerShell and do a reverse lookup and an IP address, such as the following, to see what the host name is for that IP address, we'd get a return and it would show us what the actual host name is for that IP address. And that's one of the benefits of using reverse DNS. Notice that it did query my local server because I'm on a domain controller and that's my DNS server. But if you're in a endpoint, it's going to look to your IPv4 configuration to find out what your DNS server is and query that DNS server. So we also have to understand DNS forwarders. In Active Directory, a DNS forwarder is a server that sends DNS queries for external internet-based domain names to another DNS server, like a public DNS server, instead of resolving them itself using its root hints. Forwarders are configured on internal AD DNS servers. We'll see that in a few minutes. And when the ADS server can't find an answer in its own zone, and these zones are based upon domain names, it passes the request to the forwarder for resolution. It improves the efficiency of name resolution for external sites and can improve security by controlling where the queries are sent. So normally, you don't really need forwarders in AD DNS. All the domain controllers will use the root hint servers, so internet root hint servers, to locate the top-level domains for internet DNS queries. However, if you have a different internal DNS zone that is not hosted by Active Directory, you may want to include a forwarder in Active Directory DNS that says for any of these zones, any of these domain names in these zones that AD doesn't handle, here's the IP address to contact these DNS servers internally for internal domain name resolution. And lastly, we have conditional forwarders. in Active Directory DNS. A conditional forwarder in Active Directory DNS is a DNS server based upon a domain name and a query that forwards a specific DNS request to a designated server for resolution. Unlike a standard forwarder that handles all queries not resolvable locally, a conditional forwarder is a rule-based system that improves performance, reduces traffic, and provides granular control over DNS traffic, often used for resolving names in other internal or external DNS namespaces. This is most commonly used when you are in an organization that deals with multiple Active Directory forests and you need to resolve DNS names for those other forests and those other domains inside that forest, and point to the domain controllers that have DNS set up on those domain controllers and forward those requests to those domain controllers. That's one scenario. The other common scenario is when you're in a merger or acquisition and you're migrating AD from one forest, one domain, or multiple forests and multiple domains, and you have a trust relationship set up between those domains, and you have the, wide area connection, networking set up, and all that kind of stuff. And you need to make sure that those domains, those forests, and those domains can communicate with each other for all of the Active Directory communications that need to happen in an Active Directory migration. A final note on Active Directory DNS zones and namespace. There's something called split DNS, and split DNS is where your external public DNS namespace, for instance, damoncloud.com, would be the same as your Active Directory domain namespace. So that would be damoncloud.com and Active Directory as well. And so in this scenario, you want to make sure, because you have split DNS, that your internal Active Directory AD DNS, because it has a zone file, it's going to resolve firstly, uniquely to Active Directory for domain joined computers to your Active Directory DNS, because it has a zone file for that, and not resolve publicly that all of your records that you need are duplicated in your Active Directory internal DNS zone. Now, you may want some of them to be unique. For instance, you might have an internal web server, www, that is different than your external public DNS web server. So some of those might, even point to different locations. But for the most part, they're probably going to be replicated from your public DNS into your internal Active Directory DNS for all of the services, unless those services are different on your internal network than they are on your public network. When routing internal domain joined computers to that namespace. One benefit of having split DNS is that you can have a public third-party SSL certificate that covers both your public DNS and your internal DNS as well for SSL communications. And typically that's either a wildcard certificate or a SAN certificate, a subject alternative name certificate. So before we get into the DNS server options and configurations and specific zone files, let's see how we actually get into manage DNS via Active Directory. There's a couple different ways we can do it. First method is we go into the server manager and we go to tools and we go to DNS. We do this on a domain controller, and it will automatically communicate with the local domain controller, which we see here. But we can always go up to DNS and say connect to a DNS server and following computer, and add other DNS servers, other domain controllers to our console. And we can check and make sure that, they're in replication and have the same records and all that kind of stuff. If we expand each type of zone, we're going to be able to manage those and see all the records. Here's our forward lookup zones right here. And then we'll see our domain namespace. Each one of the zones, anyways, I should say, for our domain namespaces, if we have multiple ones, and we'll see multiple zones underneath each one of those forward lookup zones. And it's the same thing for reverse lookup zones. If we click on that and expand that, we're going to see any of the subnets that we have entered for our network. It looks a little weird because it is kind of backwards. It's the first 3 octets. That's all you need. With a 24-bit subnet mask anyways. For each part of the network infrastructure that you have for, Active Directory that needs a reverse lookup zone, as well as any conditional forwarders that we have in place for, again, specific direction to DNS servers that are authoritative for that zone, typically internal. Other Active Directory servers that we are in a partnership with or a trust with, that kind of stuff. And if we click on that, we're going to see the records for that. And we'll get into the details of all this later. But as an overview, that's one way to get to it. This is Server 2025. So it's going to look a lot like Windows 11. We could actually just go here to the start menu and type in DNS. And we're going to see the DNS console and launch it from the start menu as well. And it'll bring us to the exact same place. Creating DNS records in Active Directory DNS is really quite simple. Just open up your DNS console on one of your domain controllers and then expand the DNS server. Go ahead and do that. And then we'll go ahead for our forward lookup zone and we'll expand that. And then we'll find the zone, typically in a domain, for a single domain, you're only going to have one unless you have other zones that you want to resolve outside of your single domain. And we'll just click on that. And we'll see all of our existing records. And we can simply right-click and select any type of record we want. So if we wanted to do a host record, new record, and say, for instance, test is the name of our file, and then put in the IP address, and we'll just pull one out of the hat here. And then create the associated pointer PTR record for our reverse lookup. and add host, and boom, it's done. Now we have a host A record that points a host name to an IP address. Because we said create the associated pointer record, we should see it here in our reverse lookup zone underneath that subnet. And boom, there it is for a reverse lookup on that IP address. Let's create just a couple of other quick records here. Let's create a CNAME. And we'll just say, I forgot to type in DC03 for my domain controller. It's called DC3. So I can simply say, well, I want it to also resolve with DC03. I'm going to say, okay, the alias is DC03. And I could just browse to DC3. Look through the zone and find DC3 as the host that it's going to point to as a CNAME, and boom, DC03 will point to DC3 underneath daemon.cloud.com. So if we typed in ping DC03.daemoncloud.com, look at that. It's resolving. Our CNAME works. And notice how it resolved to DC3. So that's our CNAME. Let's now do a text record like we're going to do an SPF internally. Let's say we had an Exchange server and we got split DNS. We'll do a text record now. We have to go to other new records. And go down to text, TXT, create record. And we're just going to type in the text. And we're going to leave the record name blank because it's going to use just the parent domain, which would be the @ symbol in public. And now we've got our SPF record done. Creating a reverse lookup zone is just as easy. I'm actually going to delete this one so you can see that it'll populate after we recreate it again. All right, so it's gone. Let's go ahead and recreate that. We're just going to right click, say new zone, next, primary zone, store this in Active Directory. That's how you create an Active Directory integrated zone. Now, when you create your domain controllers, this is automatically going to be there. But if you create either a new forward lookup zone or reverse lookup zone and want it to be stored in Active Directory and replicated, you have to keep that selection. It's there by default. You're pretty much going to keep all the defaults. You want it to replicate to all DNS servers unless there's a specific type of topology that you're using with replication in your domain or forest. Then you would have to consider that and change it to certain ones. But in this case, we're not going to do that. IPv4 lookup zone. And then we're just going to type in the network ID 192.168.200. And then it's going to show us right there what the reverse lookup zone name is. We're just gonna keep that. And then click on next. And just keep the rest of the defaults. Allow secure dynamic updates. And finish. And within a little while, we're going to give this some time to populate. So now we see some of those pointer records automatically updating. We're good to go. And the last type of record, conditional forwarders. We're just going to right click and say new conditional forwarder. And then we're going to try to just do google.com. I'm not sure if it's going to work because I don't really have anything that I'm connected to locally that we could use as a conditional forwarder. And what you're going to do is you're going to type in like the IP addresses of the DNS servers. And typically you want to do more than one for failover purposes. But in this case, I'm just going to use Google's 8.8.8.8. And I could say store this conditional forwarder in Active Directory and replicate it as follows to all the servers. Gives me a warning about pre-Windows 2003, but that's not even relevant anymore. And I can specify a timeout, but it said okay. So it actually is going to use this conditional forwarder if I leave it in place to forward all DNS requests out directly to dns.google.com. It picked it up instead of using my own DNS servers to resolve google.com. And so if we took a look at that, we're going to see that server in there. And we could always add more servers later by going to edit and adding some more servers in here. Just click here to add an IP address. So that's how you add a conditional forwarder. And again, what it's going to do is it's going to say, to resolve this domain name, go directly to this DNS server. And that's most of what there is to creating DNS records in the Active Directory. Okay, so the last topic is to take a look at the configuration settings. So there's two ways to configure it with different types of settings. One is at the server level, the DNS server level, and one is at the zone level for each zone and each type of zone. So let's take a look at the server level first. If we click on either one of the servers and we go to properties, we're going to see several tabs. We're not going to look at each one of these, but you might want to consider on the interfaces tab to limit the responses for DNS to the actual production adapter, so it's not doing traffic on, let's say, a load balancer or cluster adapter or anything like that on the servers. So I'm actually not using this one or this one or this one. I only want it to speak on my actual production network, so I'm going to click apply on that. Actually, I think I am going to leave the internal only virtual network for certain reasons. So I'll leave that one checked. Let's go to the forwarders tab now, which is right here. So there's a ton of important information in here. I want to just talk a little bit about this. We talked about all this already, but the sequence of DNS resolution, it says forwarders are DNS servers that this server can use to resolve DNS queries for records that this server cannot resolve. Remember, we talked about that. So forwarders are only for zones that this DNS server does not have as a local zone. But if you wanted to add a forwarder, let's say you had a network device and that network device served a certain internal zone that DNS doesn't serve, well, then you would click on edit and you would add the IP address of the forwarder that you would want to forward DNS requests to, and then anything outside of that zone that's in ADDNS, it will go to that DNS server and look for the zones that that DNS server serves. Use root hints if no forwarders are available. And we'll talk about root hints when we get to that tab. And it also says right here, note, if conditional forwarders are defined for a given domain, they will be used instead of server level forwarders. So the difference is in a server level forwarder that we would specify in the edit thing is that for any domain outside of the domains that are found in our zones here, it's going to go to those servers to try to resolve. And if it can't resolve it there, then it's up to those forwarder servers to resolve with either their own root hint servers or whatever. Unless we're not using forwarders, we're going to use our own root hint servers. But with conditional forwarders, they're going to be used for those domains, because remember, a conditional forwarder is domain specific before it moves on to forwarders. And we already saw how to do that. So that's a very important distinction. If you have a conditional forwarder for a certain domain or domains, it's going to hit those conditional forwarders first. And then you can or cannot have, whichever way you architect it, forwarders on top of that. And if you do have forwarders, then anything outside of the conditional forwarders, anything outside of your local zones in AD will then go to your forwarders. But if you don't have forwarders, it would then go to your root hint servers. So we'll take a look at root hints and then we'll come back to advanced. So our root hint servers are really our internet DNS servers for anything that's not resolved locally. And these are defaults that are built into Microsoft DNS, local DNS. Once in a while, these become outdated. So if you're getting like event logs saying that you can't resolve stuff and there's root hint problems, what I typically do is I will go into each one of these root hints servers one by one, and I'll click on edit. And what I'll do simply is I'll update them by going to edit and clicking resolve. And it'll go out to the internet and find the right IP on the internet. And I'll go through each one of those root hint servers until they're all updated and then click on apply. Now let's take a look at the advanced tab, and the other ones you just leave alone at their defaults. We're not going to go over those. The only thing I might change in here, unless there's a business case for changing some of the options, the server options above, is enable automatic scavenging of stale records. Now, we really don't have time to get into this. Is a big process. It takes a bit of architecting and you really need to know what you're doing. I might make a whole separate video on this, but I don't want to give you guidance on this because if you get it wrong, you could have some problems with DNS. But I advise you to look up how to configure Active Directory scavenging correctly. There's a wait and non-wait period and all that kind of stuff, and it's really got to, be done correctly. But after you've done your research and planned it out, definitely click on Enable Automatic Scavenging of Stale Records. But you not only have to set scavenging on the server level, but on each zone that you want to set scavenging on. So you have to enable it at the server level, and then you have to configure it on each zone or configure it for all zones. So if we were in advanced and we set up enable automatic scavenging and took the default, we still either have to come at the server level and say set aging scavenging for all zones and set to the correct settings that we need for our environment, or just take the defaults so that every zone is going to have this. Or if you have some zones that you need different scavenging settings on or none at all, then what you have to do is you have to go to the zone itself and set up aging underneath general and scavenge resource records, each zone independently. So you can do it at the server level by enabling it, and then setting enable scavenging for all zones. So there's two steps. You have to enable it at the server level on the advanced tab, regardless of how you do the second step. The second step is either do it for all zones the same way, or do it independently for each zone. Whichever way you've got to do it, highly recommended to set it up. In a nutshell, scavenging is getting rid of old, stale records so they don't cause problems with name resolution. So we just took a look at the properties, the configurations at this DNS server level. Let's take a look at some of the configurations to set or to validate at the zone level. So each zone is going to have its own set of configuration properties. So typically you might only have one zone, not a big deal. So we're going to go to the zone and go to properties. And notice it says right here, the type of zone. We didn't really get into the different types of zone because we're really focused on Active Directory integrated, but there's standalone and secondary, primary and secondary. If you found that you accidentally intended to create an Active Directory integrated zone and you created a primary zone, you can always change it to an Active Directory integrated zone so that it replicates to all domain controllers by clicking on the change button. And if you want to change the replication of which domain controllers it replicates to, I always say all domain controllers unless there's a specific topology requirement. And then you can change from secure only for dynamic updates to, there's going to be some requirements for that. So you might want to just change to non-secure and secure so you don't have issues with replication unless you set up your certificates and all that kind of stuff. It's typically what I do. Make sure the running status is running. And that's pretty much it. Other than, of course, we already went over this at the zone level. If you didn't say set aging for all zones, each zone you would have to go into aging for scavenging. And we just took a look at that. But just looking at it again, scavenge resource records. So we have to do it at the server level and the zones level. Next, we take a look at the name servers tab. And this is, again, per zone. Typically, in an Active Directory integrated zone, you want all the name servers, all your domain controllers in the name servers tab. Sometimes what you're going to find is that you're going to have legacy domain controllers that weren't demoted properly in here, and that's going to cause problems with DNS resolution. So you can remove them. If they're not resolving to an IP address, you can go in here and edit the IP addresses. So for this one, I can go in here and say, well, I don't need the 172.16.0.202 address. So I can go on that and delete it. I'm going to keep it for my purposes, though. So the name servers tab is very important on the zone. Make sure all your domain controllers are in there, and make sure the IP addresses are correct, and make sure there's no legacy domain controllers that are causing an issue. And lastly, let's go to the Zone Transfers tab. And the default should work, but I like to go in here in an Active Directory integrated zone and say allow zone transfers, but I say only to servers listed on the name servers tab. And hit apply. And I would leave the other tabs at default. And that pretty much wraps up our deep dive into DNS. I thank you for watching another video. I encourage you to like, subscribe, comment, click on the notifications bell, and share with others. And if you feel so inclined, don't forget to buy me a coffee, either as a one-time supporter or as a member. Members have exclusive content as a member. You have access to things such as diagrams and plans, project plans, those kind of things. As a supporter, you're going to have access to content that not the general public has, such as knowledge base articles and PowerShell scripts. Members have access to all content, including exclusive content. So keep that in mind. Try to support my channel if you can, and hope you enjoyed this video.